Hi, well, thank you all for coming. My name is Vince Rizzini, as it's sort of going, and my project is environment. So, basically, a little bit about me. I was born and raised in Colorado. I've lived here my whole life. I love the outdoors, everything, rock climbing, camping, hiking, all that. And I've done 4 years of computer science and STEM classes. That is like from computer science A to data science. I'm really into that. And I have extracurriculars in sports, TSA, FBLA, all this kind of for my resume. And then I'm going to be studying I'm going to be a computer science major in college. So all this kind of came together for when I was deciding my project. And with my love for the environment, I wanted to do something that kind of incorporated, the outdoors and what that entails, and hopefully something like preservation focus, because I've always been interested in that. And then I also wanted a real world application. I've taken all these computer science and math classes, and I haven't really been able to apply that to what I'm learning. And so I wanted to do something that could take all that together and hopefully implement that into my project. From there, I started researching different technologies, and especially ones that were innovative, and something that I could hopefully do that no one else had done in this class that would be new and interesting. And I also wanted to study new coding languages and different avenues of technology to explore that I hadn't ever done before. And so all that together led me to my project proposal, which is to create a decentralized app that provides environmental donation avenues through the Ethereum blockchain and smart contract technology. So that's a lot of different things all at once, but basically what that means is using cryptocurrency, and I'm sure you've heard of Bitcoin, there's Ethereum as well, that I wanted to implement that to try and connect people who wanted to work for the environment with people who wanted to donate to it locally, and then foster that kind of communication. So a visualization of what this might look like is, say I have Mr. Combs who has not a lot of time, but a lot of money, and he wants to help his environment locally. And then there's me, who doesn't have a lot of money, but has a lot of time, and so I also want to do what I can. So Mr. Combs can say, oh, I'll give you a certain amount of Ethereum, which that's the symbol for Ethereum, which is like Bitcoin, cryptocurrency. And he can give me a certain amount of Ethereum and promise that I will, pick up trash, bike to work, do fire mitigation, whatever it is to help the environment. And once I completed this, I can come back to him and show him the proof of that, and he can give me my Ethereum and the transaction can be completed. So with this, I went to design my logo for my company, and with the name, I chose environment because obviously the technology I'd be using is Ethereum, and specifically the cryptocurrency is called Ether, shortened to ETH. And then environment, obviously that was the focus of the app and the decentralized app. So I combined them to create an environment. And color scheme, I went for like a darker green to show the environment, show preservation, even show money. It kind of means. And then I wanted to have a simplistic design. So I have the tree and the black hill, and just kind of make it look simple and modern, like all of the kind of logos are nowadays. So my objectives over the course of the year was to research the Ethereum blockchain, kind of get more understanding of what that looks like and this new technology, understand decentralized application development. A decentralized app is basically any sort of web user service that uses the blockchain. And so I wanted to kind of know what that meant and the development of that looked like. And then hopefully raise money for the environment. That was a goal. And then research and understand app development itself. This kind of shifted into website development the more I kind of learned about it. And then ultimately create real-world applications to my knowledge and create connections through the project. So what my timeline looked like over the course of the year, I started off looking like this, where I developed an app and then connected it to the Ethereum blockchain. However, I didn't know at this time. And then from there, I could work on the Ethereum implementation and making that all work. But this is not actually how it works at all. This kind of doesn't make any sense, like at this point now. So I changed this completely like once I started to learn what everything actually looks like, I went to more this design, which starts by researching Solidity and Ethereum and all these different aspects to blockchain development, and then from there getting into creating a front end that users can interact with and they can connect people and transactions together. And over the course of the year, I spent more and more time on the Solidity and Ethereum and blockchain side of it, because that was kind of the meat of my project, and that's what I was more interested in. And so I figured a front end would be less important if I could have the back end, kind of everything that is involved in the contracts being complete. So as far as my advisory committee, my expert advisor is Dr. Gabriel Fierro. He was a huge help throughout the course of the project. He had some experience in Ethereum, and he had a lot of experience in blockchain technology and helped kind of explain a lot of concepts to me that didn't necessarily make sense. And then beyond that, he has a PhD in computer science from the University of Berkeley, Cal Berkeley, which was very helpful, and he knew a ton about everything that I was doing. And even more than that, he works partially at the National Renewable Energy Laboratory, which meant he had a passion for the environment and preservation like I did, which just totally overlapped with my project and was perfect. And he's also a professor at the School of Mines. And then for my support advisors, I had my dad, right there, who is chief of data science at Iterate AI, and he also has a master's in data science from UC Berkeley. And he was helpful over the course of the year in just kind of guiding me, especially near the end, with the HTML and the web development code that I had never done before. And he helped kind of guide me through that. And then Avi, he was in my class, a peer in my class, who's great at computer science. He should stay for his project later today. But he knows a bunch about computer science and cybersecurity and all that, and so he was very helpful in just kind of talking to someone who kind of knew about the topics, and I could also talk to about some new topics. And then Ali, who just kind of guided me through the class, he told me when my journals, like I needed to have them done and goals and make sure I didn't miss any due dates, and I did the same for him. We survived. So, and then Charisma helped read over my journals and kind of with checking with grammar and making sure I didn't write anything stupid. And so, as far as my research goes over the course of the year, I started off with blockchain and researching what the blockchain is, because I don't know if you've heard of it, if you've kind of dealt with Bitcoin and NFTs and all that sort of technology, you'll know what kind of the blockchain is, but basically, all these different functions that are running, cryptocurrencies, all of that are running on a blockchain that acts as a series of information. So whether that's transactions or code or just IDs and different addresses, it stores all that information on each block, and then it labels the block, and then it has the label of the block before it so that they don't ever get mixed up and they always stay in the order. And so what that connects to the important part of like blockchain is its immutability and consistency. It will not change. It's incredibly difficult, if not possible, to change the blockchain. Once you do a transaction and it gets completed and deployed onto a block, that transaction is permanent. And so that's really helpful with consistency issues. And this is kind of a problem in computer science, in that one good example that my advisor gave me for it is if I was at an ATM and I wanted to extract $20 from my bank account, and I had a friend at a completely different ATM, and we were able to, like at identical times, extract $20, the bank would see that and it'd be the same time, and they could only mark it as one transaction, because even though it happened twice, it was at the same time. And because of that, it can be a big issue, especially with financials. So the blockchain kind of avoids that by having it so that every transaction is kept on the blockchain and marked, and nothing gets missed. So, like I said before, mainly on blockchains are transactions. This is kind of a visualization of a specific block on blockchain. it has different transaction transfers and different addresses. And then more than that, what I was kind of interested in developing is code on the blockchain. And any sort of code that's been put there is called contract. So this is one of the contracts that I uploaded. It has an address, which I'll get into, and just other information regarding transaction and transaction history. So with that, I then went into the security aspect of it. And the main parts is that everything is given an address. So whether you have cryptocurrency, you'll have an address that's associated with your account and everything that you own. And then everything is kind of kept secure through private and public keys, which is just basically the cybersecurity side that I don't know too much, but it just keeps everything secure and makes it so you don't lose your Bitcoin. And then with that, there's, in order to store your crypto and your Bitcoin, however you want to do it, is wallets. So there's a bunch of different wallet companies out there. It acts just like a physical wallet. It keeps your money stored with you, but in that case, it's Bitcoin or cryptocurrency. So there's Coinbase, which is a great beginner wallet, and Electrum for Bitcoin. But Metamask is the main Ethereum wallet, and it's what I navigated throughout the course of my project. And it basically allows for you to interact with the blockchain and make certain transactions with other people. And as you can see, this is some contract work that I was doing, that it stores and commits everything, because there's a lot of different aspects to making transactions on the blockchain. There's gas fees, which basically just small charges in order to edit the blockchain and everything. And so this just navigates that for you, and it's very helpful. And as you can see, I have 2.86 ETH, which right now Ethereum is about $3,000 each. So, but sadly, that's not real Ethereum, because otherwise I would probably not be here. But I was able to use test networks, and so there's basically practice blockchains that are out there that look the exact same and everything, but the Robson's test network means that these are Robson's Ethereum, which are basically worthless, but still looks cool to have. And so then I went with and researched Solidity and different coding languages involved with Ethereum. So whenever you want to code on the blockchain, you want to make a transaction, you want to make a smart contract, everything's done through Solidity. And there's some important functions that I use that are such as mappings, which allows you to store information which you can access with another variable. So if you wanted to store money on an account, you can access that account by passing its address to it, and then the address will give back the certain value that's in the account. There's require functions, which is really important for my project in terms of making sure certain requirements have been met before a function and a transaction continues to be deployed. So this can make sure that, in my example, volunteer work has been done and people have agreed that everything looks right, that amount is agreed upon. And once that's all completed, it'll go past the require function and it can do whatever you want it to. And then ownable functions, which basically just makes it so I'm the only one who can change a certain function. As the owner of the contract, only I can access certain information, which just keeps it secure and keeps people's data secure. And then with that, I went on to Remix and Replit, which are the areas in which I coded. So Remix just looks like this. It was very complicated. I've been used to Python and Java in these different courses where when you want to run your code, you just click compile and it runs it and does everything. And this is very different because, like I said before, there's gas fees and different charges, and you don't want to be wasting money. So you have to be very careful when you're running your code. And so that was with, this is Remix, and this is Replit, and just different areas for me to use my code. And then finally, once I got a proper grasping of the blockchain and Ethereum and coding, I went on to creating a front end, something that users can interact with in order to hopefully meet other people and make connections. But I spent a lot of my time on the Ethereum side of it, so at this point I just wanted to make a proof of concept that shows that a transaction can be made. assuming two people have found each other, they could go on to the website that I kind of developed or planned out, and so they could view that transaction and the status of it, and then input information and trade money. So all this code is done through HTML, which I had to learn for this, another coding language I had to learn, and then JavaScript, which I also had to learn, and then a little bit of CSS. And so at this point, it was just learning a bunch of coding languages, and it was very tedious, but it was interesting because it's very important for what. And then, so my outcomes achieved over the year, this is called Crypto Zombies. It was kind of my guide throughout the course of the year. It's a tutorial that covers almost everything about creating a decentralized app, and so I followed it pretty religiously up until this point. That wasn't necessary, it wasn't just lazy. I swear. And so I went through all that, and that kind of guided me. And then beyond that, in terms of my own development, I became very familiar with the blockchain. I understand what's kind of happening with behind. Now when I hear influencers talking about NFTs and all that aspect, I can actually understand it, which I was really proud of. And I developed my own contracts. So this is kind of my contract, and this is a visualization of it. So this is basically a decentralized app in itself, in that you can add information to it, and you can pass another person's address in which you want to create a transaction. And then once an agreement has been reached, at which point I, as the user, as the owner, can agree upon the contract being completed, and it'll finish the contract automatically. And then with front-end development, this is where I got to, where I was able to have a front end that checks if a user has a Metamask wallet installed, or for them to actually interact with the blockchain. If not, it kind of prompts them to download it, or if they do have it, it prompts them to log in, do all that, and then I have all the different libraries involved and downloaded to check what contract I want to work on. So there's a lot of code that goes into that, in that you have to get the address of the contract you're working on, ABI, which is just a JSON file, if you know what that is, and even more just to be able to kind of connect to the contract. And then I finished my Replit Decentralized App Model, which you can see, it's kind of hard to see, but it just allows for like the visualization of what my contract and my proof of concept really look like. And that can be seen here. It has each of the important functions that I have displayed in order to check up on your contract, see if certain variables have been assigned. So if like one person has signed the contract, agreed on an amount, and everything can be visualized here. And then here as well with the other functions, in order to, if I wanted to change the owner or adjust different aspects of the project, or even just look at what's happening with the project itself. So some roadblocks over the course of the year was the updates of Solidity. Solidity is a very new coding language. The whole kind of concept is pretty innovative, but that also means that it's changing very frequently. And so it's very difficult, like Crypto Zombies I had shown before, it's not even, that's not accurate, and that's not even like a year old at this point. So it meant I had to do a lot of research, and once I found something, I might implement it and then realize, oh, there's been an update since then and this doesn't work anymore. So I have to go back and redo everything and do it again, which slowed me down a lot over the course of the year, especially with Solidity, but it was interesting kind of keeping up with it. New coding environments, I talked about before, Remix and Replit, that kind of made it difficult to interact with my code, and there's a lot that went into it more than just other coding languages, and so navigating that was difficult, because I started off with Remix, but then Replit looked nicer, and so I shifted to that, but then there was a certain thing I needed from Remix, and just switching back and forth made it pretty difficult. And then by the end, when I started to work on web development, the HTML, CSS, and Web3 JavaScript code was, when I first started the project, I thought I'd only be learning one coding language, and then by the time at this point, I was like studying 4 different languages, and so that made it really difficult to just navigate all that. But eventually, I kind of got the hang of it. Yeah. So future developments I'd like to do on this project would to be work on the CSS a little bit more. The way my web page looks like right now, it's mainly just to kind of show the function of it. It shows that you can connect to the blockchain and users can interact, but it doesn't look nice at all because all that language is just CSS, the coding language that just makes everything look pretty, colorful, and I want to work on that just to make it a little bit more user-friendly. I want to develop Solidity more. There's a lot of concepts that I learned over the course of the year that I wasn't able to implement, and so if I was able to kind of add that in the future, I think that'd be a better representation of everything I learned, even though I was able to represent a lot. And then hopefully I want to expand my website just to make it easier for users and make it so it'd be easier to connect with people. I kind of focused on the functionality of it, and it'd be cool to make it look nice, and so I could really start getting into incentivizing people to help the environment and do volunteer work. And this is my video. Any questions? Yeah.
So you said in terms of like the progress, somebody completes a task and then they're rewarded. What's stopping the person from just refusing to give the reward?
Well, that's part of, when you actually create the transaction, once the transaction is made, the contract stores the Ethereum. So once both people would agree, they no longer actually have the money that is being sent out. So it's kind of in a state where I, being hopefully trustworthy, people would trust me, and I am trustworthy, I'll say. I kind of keep track of that, and I will mark that, make sure that everything looks right. And then once the task is actually completed, then the agreement can be signed and the money will go from the contract to the person. Or if the task isn't completed, it can be sent back. And so it's kind of in between, which is nice.
How did the process of debugging throughout the entire project look like?
Well, that was one difficult part with it being a new coding language. I figured out that when my code wasn't working in Solidity, it wouldn't tell me why. It would just say gas estimation error, which is basically just saying it's not going to work when you run it, but we're not going to tell you why it's not going to work. So that made it really difficult, going over my entire code and checking to see, okay, this might not work 100%, so I have to adjust that and see if it fixes it.
I'm not sure how this applies to Ethereum specifically, but how do you reconcile the carbon footprint?
Well, that was kind of one of the inspirations for my project. I knew once I kind of researched it how, at this point, Ethereum and cryptocurrency is actually really bad for the environment. And I wanted to make something that kind of improves, takes away from that. But then even more than that, a big part of Ethereum is proof of stake. Right now, I don't know if you've ever heard of Bitcoin miners or doing that, but basically that's how all these different transactions are confirmed, is people are having computers that are running very complex math very quickly, and that's obviously bad for the environment, and that's where the worry comes from. But hopefully soon, they've been rolling it out for like over 2 years, but Ethereum is going to go to proof of stake, which basically is if I agree that a transaction is trustworthy, I will put a certain amount of Ethereum on it, I'll almost bet it, and then if it does go through, I can kind of get that back and possibly a reward. And so that's a lot more environmentally friendly. And so I started to research that and that aspect to kind of offset the negative carbon footprint.
So did you have to pay every time you went to push?
No, I would, but luckily the test networks I found were allowed it. So when I had that like 3 Ethereum, it was fake Ethereum. So if I wanted to use this on the real blockchain, it would cost roughly like $2 to $3 every time I kind of ran my code. But that's just from my side of it. So it would be different for a user if he was.
All right, well, thank you. Good job. At this time, if you guys would like to get up and move around, my people back to your tables. We'll have another presentation in about 15 minutes. Let's go ahead and interact with the kids at their tables, please.